So most engineers don't get to see what's inside a switchgear, but today you will. Today I'm standing inside a medium voltage switchgear factory and I'm going to give you a live walkthrough of this complete switchgear panel. You'll understand the single line diagram of this, what are all the components that we have used, you'll understand the bus bar arrangement and the function of each panel. And most importantly, you will see everything live from the factory. So let's jump into it. So let me first show you the rating plate of this so that you know what you are looking at. So this is a 11 kV panel. Now 11 kV is the operating voltage. The rated voltage of this would be 12 kV. And this is an outgoing panel. So the current rating for outgoing panel is 630 ampere. But we also have incomer which accepts 1250 amp as the rated current. The frequency is 50 Hertz. And of course it's a MV AIS type panel. So this is a AIS type panel or air insulated type panel. We also have GIS, which is gas insulated type. I'll explain you the difference between these two when we go through the panel. But before we go and deep dive into this panel, it is very important that you understand the single line diagram or SLD of this panel, because that will give you a very clear idea about what components we have used, how we have arranged and all the other things. So let's first go and understand the single line diagram of this and then we'll get back to the panel. But before we go there, a big shout out to New India Electricals Limited. We are standing today in their factory. They produce switchgears up to 36 kilovolts and they supply to India and many other countries. We'll talk about more on them and their products later in this video. And if you haven't subscribed, make sure you subscribe to the channel so that you don't miss any of the next updates. So alright, here is the single line diagram that we are going to, of the panel that we are going to learn today. So we have different panels here. So we have incomer 1, incomer 2, then we have 2 outgoings which is coming out of the incomer 1, and then we have 2 outgoings which is coming out of incomer 2, and then there is bus coupler and riser. Now let me explain you what do we have in incomer panel 1. So this is the panel. Now it is called as incomer because we are accepting the supply that is coming in from, let's say, a substation or maybe any other panel. And once the supply enters, we have immediate voltage transformer connected, which is connected in parallel to the system. And to that we have a fuse also connected, which helps us to protect the VT in case of abnormal conditions. And this is a single core PT 11 kV by root 3 and the output voltage is 0.11 kV by root 3. That's the potential transformer. I'll show you the detailed nameplate of this when we go to the panel. Then we have a current transformer. Now current transformer helps us in measuring the current and also it helps us in giving the inputs to the protection relays that we have. So we are using 3 cores here. So the rating is 1200 by 600 amps. That's the primary current. And on the secondary side, when the current will be stepped down, we will be having 5 amperes. Okay, it is mentioned 3 times. That indicates we have 3 cores. And then the main part of the panel, that is circuit breaker. Here we are using a 1250 amps vacuum circuit breaker. Now when you see this kind of symbol where we have the brackets, it means the breaker is withdrawable. You can remove the breaker when you are, let's say, carrying out maintenance activity or you want to swap in it with another panel. You can take out the breaker completely from the panel and carry out the maintenance activity and all the other things that needed. Now the advantage with this arrangement is that we don't need the dedicated disconnector for this, because IEC says when you remove the breaker we get the isolating distance what we need. So that's the advantage. I'll show you the rack in rack out operation as well. So that is basically our incomer panel 1. And if you look at the incomer panel 2, which is very much identical to the incomer panel 1, we have VT with fuse, 3 core current transformer and again a withdrawable type vacuum circuit breaker. So those are 2 incomers that we have. Now moving on to the outgoing one, you see we have another vacuum circuit breaker. Of course we need protection for the outgoing as well. And this is also withdrawable type. The rating of the breakers are same. And here we are using a 2 core current transformer which is rated at 600 by 300 and the secondary current is 5 ampere. So this can be used for protection purpose or maybe metering purpose. We are not using any PT here. It's not needed as well because we are taking the inputs from the VT that we have on the incomer side. So that's why the VT is eliminated here. And that's all we have in outgoing 1. Same way you can see the outgoing 2 is identical. So both these panels are identical. In fact, if you look at outgoing 3 and 4 as well, all those outgoings are identical. Now there is two panel that you see, the bus coupler and bus riser. Now these are one of the most misunderstood panels in the switchgear lineup. I'll show you what is this, what is the purpose of this when we go and check out the panel live. All right, so that is the basic single line diagram of the panel that we are going to look today. Now let's get back to our panel where I explain you what is inside. So we are back at the panels and I am going to talk about what is inside and how these panels are arranged. Now as we have seen in the SLD, we had two incomers and every incomer had two outgoings. So you can see this is our incomer 2 and then we have two outgoings there, and there we have incomer 1, two outgoings, and then we also have bus coupler and bus riser panel. I'll talk about these two later when we explain about all the panels. Now first let's start with what is there inside the incomer panel. Now if you remember, we saw the first thing was the cable entering into that, which you can see at the back side of the panel. There is arrangement where the cables can be entered, and after that you will see a voltage transformer connected, which is connected in parallel with our system, and a high tension fuses are also connected. So in case the current increases, we must need something to protect our transformer, right? So those fuses will help us in doing that, and it's a single core voltage transformer. You can see the rating plate as well there. So from there we are going back to the current transformer, which you can see at the back of the panel. The current transformer is needed so that we can step down the current, because the meters and all that we have on the low voltage side cannot accept the current that is coming inside the panel. So for example, this is incomer 2 and we have 1250 ampere as the current. So the relays, the meters are not meant to accept that current. So we must step it down, and for that we are using current transformer, and voltage transformer as well we are using for the same purpose. The input of that voltage and current transformer will go inside the relays, inside the panel meters, that will help us in measuring and protecting our system. So here this is the current transformer that we have. This is R phase, this is Y phase, and this is B phase. So this is a window type current transformer. You can see the bus bar is passing through this and then getting connected to the circuit breaker. After that we come to our circuit breaker part. This is the heart of the switchgear, very important device. If this fails, then there are very less chances that your switchgear will be saved or the system will be saved. So we are using a vacuum circuit breaker rated for 12 kilo amperes. 1250 ampere is the rated current for this breaker. It's a vacuum breaker, and we can remove this breaker and put it back when we need it. This is called as withdrawable type circuit breaker. Now the advantage with this, we already talked about this. When you remove this breaker, we also get an isolating distance between the two live wires. That basically serves as an isolator. So when we use this withdrawable type circuit breaker, we don't need a dedicated disconnector or dedicated isolator supported by IEC standard. And that's why you will see in any of the panels that we have here, we are not using any isolator. But when we go to the gas insulated switchgear, there the breakers are not withdrawable. It's a fixed type, and for there we definitely need the disconnectors. All right, so that is the circuit breaker. You can see the different switches here. We have two switches to push on, push off. Then there are emergency trips. So in case something goes wrong, you need to emergency close the breaker. We have the switches here. This is emergency trip. And then now we move towards the next part, which is the low voltage side of the panel. Now these are different chambers, what we can call. The bottom chamber can be called as the cable chamber, because we are accepting the cables there. The middle portion is the circuit breaker chamber, and then we enter into the third chamber, which is the low voltage chamber. Now why this is low voltage? Because we are not handling any 11 kV or 12 kV inside it. We will always have 110 volt DC or 220 volt DC, which is much lower compared to what our system is giving us. So that's why this is called as low voltage panel. Now let me quickly show you what are all the things that we have in this low voltage side. Alright, so here are the indication, and before we go into the indication, this is also called as the relay and metering chamber along with the low voltage chamber. So first you can see on top we have different indications. We have R, Y and B phase healthiness, so that means the voltage is available there and they are perfectly working fine. Then these are the two indication about the breaker. In fact, the fourth also. You see the first one is breaker on, breaker off, and this is for breaker trip. and then breaker spring charge. So all these 4 indications are for breaker, which is coming from the breaker's auxiliary switch to our low voltage side of panel. And we have a multifunction meter here, which will help us in measuring different kinds of parameters that we have. It will show us all the time. And this is the relay that we have, and it helps us with the different types of protection. You can see the ANSI codes for those are given here, and everything. This is kind of the master relay for this particular panel. So like this, we'll have relay for all the panel except for the bus riser panel. And then we have the annunciator here. You can see the different indications are marked. So overcurrent trip, if that happens, you'll get the indication. This is earth fault trip, you'll get this indication. And then we have 2 spare items provided. So in case if you want to configure it for some other things, you can do it on your own. And then importantly, we also have a hooter here, which will make noise when something goes wrong with this particular panel. Like this, we'll have hooters for every panel so that we know which panel is faulty, which panel is tripped. And moving on, we have a breaker control switch. This is called as TNC switch. The reason is pretty obvious, because we have trip, neutral and close button. If you want to trip, you can just make it here. It will trip. This is neutral condition and this is the close condition. And additionally, we also have a local remote selector switch. So in case if you want to do a local operation, it must be on the local side of the indication. Then only you will be able to trip it locally. It's a interlock, we can say. If you want a remote operation, we just switch it back to the remote side and it will go to the remote operation where we can do a SCADA operation or from a control center. And the last one is the reset push button, which is connected to our relay. So in case the breaker trips and if you want to reset it, just press this push button and the relay will be resetted, and you will be able to close the circuit breaker and the current will start flowing again. So we have here the relay. This relay is withdrawable. That means you can remove it when you want and then put it back when needed. Now this is super important when, let's say, the relay of this particular panel has gone down. You can take out this relay, put it back temporarily and solve the issue. So this is a withdrawable type relay. So that's everything that you see on the low voltage side or the metering and relay chamber side. So we have seen the overview of what we have in the Incomer 2 panel. The same identical equipment and apparatus you will find in Incomer 1 as well. Now going back to our outgoing panel, you will see the same relays, same functions, maybe some indications are different, but more or less you will find the same apparatus. The function is that, now why we call it as outgoing or let's say incomer. The reason is pretty simple, that we are accepting supply in this particular panel, which may be, let's say, coming from substation or any other side. And then we have outgoing because this is also called as a feeder, because this panel will help us feed the supply that we have, or the feed other factory that we are going, or a feed any other substation that we are providing supply to. That's why its name is outgoing. Here is the circuit breaker panel, exact same circuit breaker that we saw in the Incomer 2. But we are not using any voltage transformer in this particular panel. The reason is obvious, because we are getting the supply directly from the VT that we have in Incomer 2, and that will be feeded in the relays in the meter, right? And then the outgoing will go. Exact same panel you will find outgoing 4, and both the 2 outgoing panels that we have are exactly identical with each other, right? So those are Incomer and outgoing panel. Now coming to the most confusing part of the switchgear panel, and that is the bus coupler and bus riser. Let me explain you why we need this and why do we use it. Alright, so here we are with the bus coupler and bus riser panel. Now why do we need this? Let me explain that to you. So we saw we have 2 incomers in our panel lineup, Incomer 1 and Incomer 2. Now there is high chances that the one incoming is coming from, let's say, one substation, the another incoming is coming from another substation. Now imagine something goes wrong with the Incomer panel or the Incomer 1 supply. Alright, so whatever outgoing we have connected to that particular supply or that particular panel will also lose the supply. And imagine if we have connected a very critical customer, for example, maybe a data center or a hospital, and they lose the supply, it's a big thing, right? If something goes wrong, if it is connected in a factory, the factory will lose millions and millions. So we need a supply redundancy, a supply reliability. So we need a backup plan. So even in case the Incomer 1 fails, we can still feed our customers, feed our load. And since we already have incoming 2 coming from a different location, we can actually connect these two supplies together. We can, couple these two supplies together so that we can get the reliability of supply that we want. And that's the exact function of why we have this bus coupler panel. As the name suggests, it helps in coupling the two bus bars or two supplies together when we want them. Now, of course, you cannot connect all those three things together. It will create a short circuit, so please avoid that. In order to close this breaker, either of the supply, either incomer 1 or 2, must be open. Only when you will be able to connect this and the link between the two supplies will be closed and the supply from incomer 2 will flow in the outgoing of incomer 1 as well. Thereby, we can achieve the supply reliability. And that's why we need the bus coupler in the system. Now, the question is, do we always need it? Maybe not. If you have multiple supplies, it makes a good choice that you should have the bus coupler. But if you have only one supply, there is no use of bus coupler in that case. So to have the supply redundancy, to have the supply reliability, we must have the bus coupler. And it's simply a series connection of two bus bar. In that series connection, we are putting a circuit breaker so that it doesn't create a short. And this is the circuit breaker that you can see. Rest everything is same. We have indication panel, and then there won't be any VTs also here. So that is the function of bus coupler panel. Now the question is, why do we need bus riser? And you will see absolutely it's blank. There is no low voltage side to it. There is no meters. There is no relay to it. And even if I open this and show you, there is no breaker to it as well. Why do we need this? So in order to understand why do we need bus coupler panel, we have to get back of the panel where I can show you the bus bar arrangement, and you will get the clear idea of that. So now let's get back to the panel. All right, so now we are at the back side of our panels, and you can see the bus bars are clearly visible. So this was our incomer 2 panel, which I explained to you. You can see the bus bars that are connected here. And from this bus bar, we are feeding the outgoing 3 and 4 to this. Similar way, we also have incomer 1, which is feeding the supply to outgoing 1 and 2. But these two things are not connected together. And to connect that, what we are doing is we are adding a series connection, which you can see right here using a circuit breaker. Now it's a switch inside the series connection. So only when we close that, the current will flow. And you can see if you close this circuit breaker, when both of the incomer circuit breakers are in closed condition, will definitely have a short circuit. So to avoid that, we put interlocks in the system. You won't be able to close a bus coupler breaker when both of the circuit breakers are in closed condition. There can be possibility of mechanical interlocks as well as the electrical interlocks. So you can see the bus bars are coming that way. We have connected a circuit breaker here. It's a series connection, right? So we have incoming this for circuit breaker, and then the outgoing is coming out of the circuit breaker here. We have a current transformer placed, and then you see the bus bars are going down. Now these are going down because we have to connect it in vertical positions. That's how the breaker accepts the supply, right? We cannot rotate it and put it in that panel. That's not possible. And that's the reason why the bus bars are going down. Now, if you want to connect the incomer panel, you'll have to run the bus bar at the bottom and then connect, which is not ideal because our bus bars are running from the top, right? So in order to put these two bus bar in the same level, we need to raise the height of the bus bar so that we can connect the incomer 2 to our main bus bar, right? And that is what we are doing. You can see the bus bars here. It's coming horizontally at the bottom, and then we have connected the bus bars here, and we are just raising the height of the bus bar. And that's the reason why we call it as the bus riser panel. You will see we don't have any breaker, we don't have any VTs, don't have any CTs, no relays, no meters, nothing. It's just helping us in raising the height of the bus bar. Once the height is raised, you can see we have connected the second bus bar to this one. So it's now a series connection. You can see the bus bars are coming like this, going down, again horizontal, going up, and then connecting to the main panel that we have. And that is the very reason why we need bus riser panel. You can see bus coupler and bus riser. That's the whole reason why we have the bus riser panel. So as I mentioned, this is an air insulated type of panel. Now what is the difference between air insulated and gas insulated? Let's understand that. So you see we have three phases here, R phase, Y phase and B phase. And in between these two phases, the insulation at the moment is the ambient air that we have. So that's why we call it as the air insulated switchgear. But let's say if this is a gas insulated switchgear, then we would be adding the SF6 gas or any other insulating gas to this, and that is what we call as the gas insulated switchgear. Now we also have a vacuum circuit breaker there, which you can see the terminals. Now inside that, of course, vacuum is the insulation, but between the phases, even this part here, it is with air, and that's why it's called as the air insulated switchgear. If it had been a GIS, then we would be using insulating gas which is not air. So that's the basic difference between AIS and GIS. So we have seen what's inside the panel, what is the function of each panel, the single end diagram of it, and how the equipments are arranged. I hope you understood the different composition of the panels and how they function. Now it's very important. Now we have seen the complete lineup, but how do we make sure that these panels are good enough for our supply? Will they be able to take the high voltage that is occurring in the system? Well, to make sure the panels are good, the insulation strength of the panels are good, we perform the high voltage test on it. It's also called as the power frequency withstand test. Now, if you want me to make a dedicated video where I can show you how the test is performed, how the connections are done, then just comment HV test in the comment section below. If I get enough comment, then definitely I'll make a request to the management team of New India Electricals to allow us to shoot for that test as well. If I get enough comment, for sure that video is also coming. Now, before we end this video, a big shout out to New India Electricals for allowing us to shoot in this factory, because it's rare to get such opportunity, and I thanks them to trusting on us for that. New India Electricals, they produce switchgears up to 36 kilovolt and they supply it to India, Africa, UAE, Nigeria and a lot of other countries. They are also one of the major suppliers for industrial motors. If you want to know more about their portfolio or get in touch with them, just check out the link that is given in the video description. Thank you so much for watching, and please make sure if you want the test video, comment HV test in the comment section. Thank you for watching, guys. I'll see you in the next one, but till then, keep watching, keep learning.